Welcome. All right, let's review reference angles. All right, so reference angles are angles between 0 and 90 degrees. They're greater than 0, less than 90. Or in radians, that's between 0 and pi halves. Right? That reference angle goes from the terminal side of a principal angle straight to the x-axis, and it's the fast way. Right? So, for instance, if we have an angle that is in the second quadrant, the fast direction would be from the terminal angle right to the negative x-axis. Right? How do we get that value? Right? We take our principal angle and subtract from 180. Right? Because together, the principal angle plus the reference angle equals 180. So to find the reference angle is just 180 minus the principal angle. And this is in your notes. Right? So in degrees, right, we would subtract our principal angle from 180. If we're in radians, 180 degrees is pi radians. So this is in degrees, this is in radians, right? So reference angle equals pi minus the principal angle. And you have that right here. So it is not important whether you write it down if you understand it from the little chart there. Right? If we're in the third quadrant, right, then 180 plus the reference angle, oops, excuse me, plus the reference angle equals the principal angle. Right? The principal angle goes past 180 degrees, right? It goes into the third quadrant. So if we add this part here, which is 180, and we add this part here, right, which is our reference angle, we'll get the principal angle. So together, the 180 degrees plus the reference angle equals the principal angle. The reference angle, we go from the terminal side back up to the negative x-axis, because that's the shortest way, right? And that's gives us an angle that's between 0 and 90, or between 0 and pi halves, right? That we can use to evaluate the principal angle. So since 180 plus the reference angle equals the principal angle, the reference angle equals the principal angle minus 180. Okay. In the fourth quadrant, the principal angle plus the reference angle together equals 360 degrees. Right? So our principal angle is going into the fourth quadrant. Our reference angle is just from the terminal side of that angle back to the x-axis, and this time it's the positive x-axis. Notice that together the principal angle and the reference angle add up to 360 degrees. So that means that if we take 360 degrees and subtract the principal angle, we'll have the reference angle. All right, so just to recap, in the second quadrant, the reference angle is 180 minus the principal angle, or in radians, pi minus the principal angle. In the third quadrant, the reference angle is the principal angle minus 180, or in radians, the principal angle minus pi. In the fourth quadrant, in degrees, the reference angle equals 360 minus the principal angle. And in radians, that would be 2 pi minus the principal angle. in quadrant 1, the angle is its own reference angle because it's between 0 and 90 degrees. So let's do some examples in the 4 different quadrants, actually 4 different quadrants. I did decide to do one in the first quadrant. All right, so let's say I have an angle that's 80 degrees, all right? So this is 0, this is 90. Actually, you know what? Let's make it in radians. We should practice radians. I'll tell you what. I'll do half of them in degrees and half of them in radians. There we go. All right, so 0, 90, 180, 270, and then back to 360. All right, so 80 degrees is in the first quadrant. It's not quite the 90 degrees there. All right, and this 80-degree angle is the reference angle. So here, our principal angle is 80 degrees. The reference angle is also 80 degrees. Notice if we wanted to go back to the x-axis, the shortest way is to go right there. All right, so we never leave the first quadrant. Oh, and they're attached. That's all right. Actually, I'll leave that in there. All right, so in the first quadrant, the reference angle equals the principal angle. All right, so now let's do one in radians. Let's do 5 pi 8. All right, so this is 0. This is pi halves. If we're in 8, so let me write that down. So our principal angle here equals 5 pi 8. All right, so pi halves is the same as 4 pi 8. 4 looks a little weird. Right? And then this would be pi. Pi is the same as 8 pi 8. All right, so 5 pi 8, right, is going to be in the second quadrant. Right? It's more than 4 pi 8, but less than 8 pi 8. Right? So let's graph that. It's a little past. Right? Pi halves. So this here would be 5 pi 8. That's our principal angle. The reference angle is going to be pi minus the principal angle. And that's because we're in the second quadrant, right? Together, the principal angle plus the reference angle is going to equal pi, or 180 degrees, right? So the reference angle is pi minus 5 pi 8. Pi is the same as 8 pi 8. So that would be 3 pi 8. So right here, this angle here is 3 pi 8 because we're measuring that right back to the x-axis. And there we go. We found the reference angle. So by the way, this is like 1/2 of the work in evaluating an angle. Is to graph it, right? Find the reference angle, which it depends on which quadrant you're in, right? You're either, if you're in the first quadrant, you don't have to do anything because the reference angle and the principal angle are the same thing. If you're in the second quadrant, you're going to subtract that principal angle from 180 or pi to find what's left over between the x-axis and the principal angle, right? And that becomes your reference angle. Right, and now let's look at the third quadrant. So I'll do this one in degrees. Let's make this one 250 degrees. All right. So again, this is 0. This is 90. This is 180. And this is 270. All right, and I said 250 degrees. All right, so that's more than 180, but not as much as 270. All right, so there we have a 270 degree angle. In the third quadrant, the reference angle, which is just that, we're going back to the x-axis there, right, is just that angle between the terminal end and the x-axis. Right, so to find out how much this angle is, right, for our reference angle is going to be the principal angle minus 180. Right, so that's going to be 250. Oh, I wrote 200. I don't know if I wrote 270 or 220 here, but either way, that was supposed to be 250. That's what we were graphing. I'll write that again. Oops, it's stuck. Now I'll erase it. Right, so this was 250 degrees. Right, so the reference angle would be 250 minus 180, which is 70 degrees. Right, so if you're in the third quadrant, you subtract the principal angle from 180 if you're in degrees, or, you subtract 180 from the principal angle if you're in degrees. You subtract 180, you subtract pi from the principal angle if you are in radians. All right, and that's how you find your reference angle. And that reference angle becomes the angle of interest in the reference triangle. Now, none of these would be used for reference triangles because these are not friendly numbers to evaluate. They're not from the special right triangles. But that's okay, because we're not going to evaluate these angles. We're going to evaluate the next set of angles. So I purposely made them not all that friendly because we're just practicing reference angles. The steps will be the same whether the angles are pretty or not. All right, and then let's do one more in radians. And this time let's do 11 pi. No, we'll do 11 pi twelfths. All right, so this would be 0. This is pi halves, oops, which is the same as 6 pi twelfths. Oh, wait, so excuse me. Let's do 20, I made it too small. Let's do 23 pi twelfths. This would be pi, which is the same as 12 pi twelfths. Oh, by the way, so here's our principal angle. And so that's what we're gonna find the reference angle for. This is 3 pi halves, which is the same as 18 pi twelfths. I guess I could have done 19 pi 12, huh? Because I wanted to be in the fourth quadrant. And this would be 24 pi 12ths, or 2 pi. All right, so to find our reference angle in the fourth quadrant, the reference angle is going to be 360, or in this case, because we're in radians, 2 pi, minus the principal angle. Right, so that means the reference angle is 23 pi, 2 pi is 24 pi twelfths, minus 23 pi twelfths, means the reference angle is pi twelfths. Right? Oh, let's graph that. Oh, I forgot to graph it. So 23 pi twelfths is in the fourth quadrant, right? Because it's more than 18 pi twelfths, but it's less than 24 pi twelfths. All right, so here is 23 pi twelfths, and then our reference angle heads back to the x-axis, right, in this case the positive, and is pi 12ths. It's kind of messy, isn't it? It's the pi that's all smooshied. There we go. Right? And that's all there is to being able to graph and find reference triangles. All right, so you just follow the rules to help you get back to the x-axis. Right? First quadrant, you don't have to do anything to find the reference angle. Second quadrant, you subtract from 180 or pi. In the third quadrant, I'll move this up a little bit. You subtract 180 or pi from the principal angle. And in the fourth quadrant, you subtract your principal angle from 360. Right? And so this was not in your notes, but you could add it if you'd like, especially if you're having trouble at all finding reference triangles. In the next video, in the next Nearpod, we're going to review again how to evaluate angles. And that's going to be our last review skill. All right? So thanks for watching, and bye for now.